In this video, I break down the solution for challenge number 16, preservation of Ethernaut CTF. This video is part of a series of all the solutions for all the challenges of Ethernaut CTF, so stay tuned for more. I also explain the reasoning behind the solution so that anyone can understand it and do it themselves too, right? So if you are into this kind of stuff, you are in the right place. Hello and welcome to DecentraWise channel. My name is Pedro, and here we share all things Web3 development, blockchain development, and security. So if you like this kind of stuff, stay tuned. Let's move on. Let's go to our Ethernauts page. This is it, and we have all the challenges here. And as you can see, this is the 16th in this preservation, right? You also need to have MetaMask installed and all those things. So if you have any difficulties or don't know how to set that up, add to our first video in this series where we go through all that stuff, right? And then we need to choose our challenge, preservation, click here, and we need to open our console so that we check that we have the challenge opened correctly, okay? And interact with it, right? So there we go. We have our challenge here, and they are asking for us to claim ownership of this contract, right? Claiming ownership is always good. This is a contract that works like a proxy, right? Using delegate call. That's one of the most tricky calls, and it's very easy to get wrong. So usually when we have contracts with delegate calls, we need to be very careful using them, right? The best way is always to avoid delegate calls, but if we need some kind of proxy or upgradability or stuff like that, you better know what you're doing, right? It's very easy to get this wrong. So the most important thing to understand is that the delegatee and the delegator need to handle their storage correctly, right? So the delegator contract holds the storage, and the delegatee will use that storage, right? So what is common is to have this storage structure layout replicated in the contract that works like a library, which is clearly not the case, right? So we have a problem here. This is because when you use delegate call, you delegate the code execution to this contract over this storage in this contract, right? So this guy will manipulate these storage slots, right? And we have this storage slot, stored time, in this contract, which is the first slot, right? Slot number 0, being set from the outside world, from a parameter, right? So what happens in this case is that when you set the stored time here, you are not storing it here in this variable. You are storing it in this variable, time zone library 1, right? So what can we do with this? We can do a simple thing. We can substitute this library contract with our own contract, which does different stuff. Let's do it, right? So in order to do that, let's get our, not this one, sorry. Get a new instance. Let's go. There we are. We have our instance. Let's get it. There we go. 0x1ac. And we need to go to our remix and create a new file. new file. It's preservation.sol. There we are. And in this, we will get our code, this one. Okay, so we have all references here and the interfaces. And now we can create our contract, preservation, attack. There we go. And now we are good to go. So what we need to do in this contract? First of all, this contract will be used as instead of this one. So we need to have a function set time just like this one, but we'll do different stuff, right? So let's do it. We have a set time function that we can do stuff. Of course, it's not stored time that we need to do, right? And we need to have a constructor that gets the victim address, right? Needs to get address victim contract and needs to do stuff. So we need to call in the constructor the set first time. This set first time delegate calls the set time function and passes it the timestamp, right? And the timestamp is a uint 256. So we need to pass it uint created by our address, the address of our contract, right? So that we get to be in the place of this address, this one here, right? So let's do it. How can we do that? We just use preservation and victim. It's our victim address, right? And then we call set, what's the name? Set first time. There we go. And we pass it uint 160, which is the size of the address, and pass our address this, right? And there, with this call, we set our contract, this contract, preservation attack, to be the library 1, this one, right? Because we set this stored time, which is slot 0, which overrides this slot. And then we will call afterwards this function, again, this set first time, and we will end up in this function instead of that one, right? And this function can access all this, right? So we just, to simplify, we just need to copy this here. There we go. And by copying this here, we can access all the slots, right? And in this place, in this function, we will set the owner equals to what is our owner. So if we are in this contract, and if we put address, this is our address. If we put message sender, it's this contract. So we need to put it transaction origin, which is our address, our own address, that of the caller, right? And now we can, just to be to cover our tracks, we can set the library 1 to the value that we pass here to this set time, right? Which can be how can we do that? We can pass the address here. Let's just store 0, just because we can. So let's do it. Time zone library 1 equals to address 0, and that's it. Okay, and we just removed our contract from there so that no one knows who's there. Of course, in blockchain everything is public, so if they want to track us and to track our contract, they will. So don't think you can hide in blockchain. It's not easy. But anyway, it's done. We have our contract. So let's check if it compiles. It compiled, has 3 warnings, not a big deal. So we can deploy our preservation attack. We need to grab our instance address, copy, that's it, and paste it here. But before, let's do some checks here. Let's await contract dot time zone 1 library. It's this address, and the owner is this address. So the instance level and this address, the time zone, it's something different. It's F88, blah, blah. Okay, so this is the state of our contract. Let's deploy, and there we go. Confirm in MetaMask, and we deployed our contract. So we have our preservation attack here, okay? And now let's see what changed. So the owner should be the same, still, exactly. And the time zone library should be different, 0xCE something. So it's the address of our 0xCE of our deployed contract, as you can see, right? So we were successful in the first part. Now let's perform the second part, which is await contract dot set first time 0, just because we can, right? And this will call our function, which will set the owner, hopefully. Let's see. There we go. MetaMask. There we go. We have a transaction receipt. So let's check our owner. And there we go. We are the owner of the contract, right? And just for our curiosity, the address in time zone 1 library is 0. Okay? So this is it. We took ownership of this contract. Let's submit the instance to see if we were successful. There we go. Confirm. And boom. We were successful. We were successful, guys. So always take very much caution when you use delegate calls. First of all, avoid them. Only use them when it's very, very strictly necessary. And if you can, use stuff that is already implemented. But even then, if you don't understand how storage works and how delegate call works with storage, you might be trapped. So learn how it works. Understand that the delegator and delegatee need to share all the structure, all the layout of storage. There are some other patterns that you can use, like use a storage contract and inherit it in both other contracts, stuff like that. There are spacers for storage so that you know always how much storage each contract occupies. Check for patterns and use them, and understand really how storage works in EVM chains, right? And then you are good to go. But this is a very typical example of many hacks, right? So be careful with that. Hope you learned something. And if you did, you know what to do. Smash that like button and subscribe, because we are always sharing videos like this. And enjoy, and see you in the next video. Cheers. Bye-bye.